Hello, this is Lynn McCool. Today I want to talk to you about instructions and documentation. There are three categories of documentation: instructions, which describe how to perform a specific task; specifications, which describe in exact detail how a product is assembled or how a routine process is completed; and procedures or protocols, which ensure consistency and quality in a workplace by describing situations and methods. Here are two diagrams that help you to see the similarities and differences between the instructions and specification models. You can see on the instruction and procedure side that each one has a title, an introduction and a background, a list of materials, parts, tools, and conditions, and then a stepped process which finally leads to a conclusion and any troubleshooting if needed. Both graphics and safety information appear throughout the document as needed. For specifications, we again begin with a title, an introduction and background, and then we move to materials and conditions, the stepped process, and then finally end the document with measurement, test, and quality control procedures. The basic features of instructions or specifications include a title, which is specific to the subject described, an introduction with background information on the subject, parts list that identifies materials, tools, and conditions needed, any safety information which helps users to avoid injury or product damage, steps which are sequentially ordered and numbered, graphics which illustrate the steps, and a conclusion which signals the completion of the task. As you're planning, it's important to ask the right questions. So as you're thinking about putting together your set of emergency instructions, you'll want to answer and ask these questions: who might use this documentation? Why is it needed? What should it include? Where will it be used? When will it be used? And how will it be used? In planning for the rhetorical situation, again, we want to think about subject, purpose, readers, and context of use. For our subject, we want to think about who's going to use the product or follow the process, and what is it and what does it do, and are there any unexpected dangers or difficulties. For your purpose, compose a one-sentence purpose statement and use key verbs such as to instruct, guide, show, lead, illustrate, direct, explain, train, teach, or tutor. Here's a couple of sample purpose statements. The purpose of these instructions is to show you how to use your new QuickTake i700 digital video camera. These procedures will demonstrate the suturing required to complete and close up a knee operation. These specifications illustrate the proper use of the Series 3000 router to trim printed circuit boards. Each one of these has a statement that tells the reader what they are going to be doing with the documentation. Remember that you have your 4 levels of readers: primary, secondary, tertiary, and gatekeeper. And your primary readers are the people who will use your documentation to complete a task. Secondary readers are your advisors, people who might supervise or help the primary readers complete the task. And two things you want to ask yourself about secondary readers: first of all, what is their skill level? And then secondly, are they training or teaching your primary readers? Tertiary readers often use the documentation to ensure quality, and the gatekeeper readers, which may or may not be experts in your field, will look over your documentation before it's sent out with a product or approved for use in the workplace. So gatekeeper readers check for accuracy, safety, and quality. As far as context of use is concerned, we want to always think about safety and liability issues. So ask the question, when and where will your readers use this documentation? Each of these different places and times will require you to adjust your documentation to your readers' needs. A good set of instructions also requires researching. So you want to look at the background and history of the product, observe subject matter experts, use sensory detail, motion and change, and collect visuals and graphics. As you're doing background research of the history and purpose of the product or process, you might ask, if this is new, why was it developed? And if it isn't new, if it's old, how has it changed or evolved over time? You can collect prior instructions and procedures or specs for comparison with the new one that you're creating. You also can make observations of people using the product. Observations can help you anticipate some problems readers will experience. It's always good to ask subject matter experts and interview them for insights on the product. You can use your own senses to experience the product or process, and describe motion and change, and pay attention to the movements of your subject and the way it changes as you complete the steps. And then collect visuals to use as graphics to help illustrate the steps that you're describing, which is very important, by the way, to have visuals along with text. Okay, let's look through each part of the document itself. So we'll start first with the title. You should have a specific and precise title. Look at this first one. This is not descriptive at all. RGS 90X telescope. Instead, create a descriptive title, setting up your RGS 90X telescope. Here's another example that's not descriptive, head wound trauma. A descriptive title would say, procedure for treating head wound trauma. Your introduction includes several different moves, and its length depends upon the complexity of tasks and readers' prior knowledge. So first, you want to have a purpose statement. State your purpose in one sentence. Here's an example. These instructions will help you set up your RGS 90X telescope. Next, you want to state the importance of the task, either the importance of the product or the gravity of doing the task correctly. Your RGS 90X telescope is one of the most revolutionary telescope systems ever developed. You should read these instructions thoroughly so that you can take full advantage of the telescope's numerous advanced features. Third, describe the technical ability for this product or process. In doing so, consider the age, qualifications, education level, and prior training of your readers. Here's an example. With advanced features similar to those found in larger, more specialized telescopes, the RGS 90X can be used by casual observers and serious astronomers alike. Some familiarity with telescopes is helpful, but not needed. It's always useful and helpful to identify the time required for completion, so estimate the time needed to complete all the steps. Initially, setting up your telescope should take about 15 to 20 minutes. As you grow more familiar with it, setting up your telescope should only take about 5 to 10 minutes. Next, you want to motivate the reader by setting a positive tone. You also want to motivate the reader to do the job right or strive for the highest quality. Here's an example. With push-button control, automatic tracking of celestial objects and diffraction-limiting imaging, an RGS 90X telescope may be the only telescope you will ever need. With this powerful telescope, you can study the rings of the planet Saturn or observe the feather structure of a bird from 50 yards away. This telescope will meet your growing needs in astronomical or terrestrial viewing. Next, you want to have a list of parts. So list of parts, tools, conditions, anything that's required for completing the task follows the instruction in its own section. Create a parts list that allows the readers to check whether all the parts were included in the package, and any other items not included should also be mentioned here at this point, such as batteries or paint. Make sure also that you identify tools required for the reader so that the reader can gather them before beginning the stepped process. Finally, you want to specify special conditions that might involve temperature or humidity or lighting up front. So here are some examples. Paint is best applied when temperatures are between 50 and 90 degrees Fahrenheit. Or, if the humidity is above 75%, do not solder the microchips onto the printed circuit board. High humidity may lead to a defective joint. As you're organizing the body of your instructions or procedures, you want to think about creating sequentially ordered steps. Your sequentially ordered steps should have a logical and concise flow, and you can use something called logical mapping to identify the steps in the task. So you'd first start with a task, and then move out to each step. Here's step 1, thinking about any minor steps that might be associated with that major step, and also any hazards that could be associated with that step in the process. And you can repeat that for as many times as needed for however many steps there are in the procedure. So again, use sequentially ordered steps, divide them into major and minor steps. Use command voice, put the verb first in the sentence with the action up front. So here's an example. Place the telescope in an upright position on a flat surface. Another thing to think about in creating your steps is that you only want one action per step. Let me show you first an ineffective set of steps. Place the telescope securely on its side, as shown in Figure 4, and open the battery compartment by simultaneously depressing the 2 release latches. Here we have 2 steps actually, place and open. What would be better is to actually separate the steps. So number 1, place the telescope securely on its side, as shown in Figure 4. 2, open the battery compartment by simultaneously depressing the 2 release latches. There is an exception to this rule if two actions needed to be stated in one step. Completion of the first action should require the other action to be handled at the same time. You also want to keep your steps concise. So use concise wording to describe each step. Here are some examples. Adjust the focus of the telescope with the focusing knob. Center the observed object in the lens. You can also number steps that are in a list, but remember this, do not use numbering for notes or warnings because they do not state steps to be followed. So here is an incorrect example. You see here's the step, aim the telescope with the electronic controller. But the second thing that's actually listed as a step, it really isn't one. Your controller is capable of moving the telescope in several directions. That's actually just a note of information. So it would be better to word it like this. Step number 1, aim the telescope with the electronic controller. Note, your controller is capable of moving the telescope in several directions. There is an exception to this rule, and it has to do with procedures and specs, which often use an itemized numbering system, as you see here. And so if you are using an itemized numbering system, then you can put the note as a subset, a subnumber under one of the steps. You can see the caution information there. After each step, you can include additional comments or examples that might help your readers complete the action. So here you see, locate a place to set your telescope. I'm using that use style there. And you can provide feedback after a difficult step or group of steps to help readers assess their progress. When you finish these steps, the barrel of your telescope should be pointed straight up. The tripod should be stable so that it does not teeter when touched on the ground, and the legs of the tripod should be planted firmly on the ground. Another thing that you want to think about in your process is also including graphics. And you should refer to your graphics because they should be labeled and captioned. And so you can refer to them as easily as saying see figure 4 or putting it in parentheses as shown here on the slide. Safety information should be placed early in the documentation and in places where the reader will complete difficult or dangerous steps. And there are 4 levels of safety information. There's danger, which is the highest level of warning. Serious injury or death could occur, and you can see the example there. There is warning level. Here the reader may be injured if a step is done improperly. Again, you can see an example showing that. Caution level. These are mistakes which may cause damage to the product or the equipment. So with safety information then, you should tell readers 3 things. You should tell the reader what the hazard is, the seriousness of the hazard, and how to avoid injury or damage. As you move into the conclusion of the document, you want to signal the completion of the task. Tell readers that they are finished with the steps. Here's an example. Congratulations! You've just finished setting up your RGS 90X telescope. You will now be able to spend many nights exploring the night skies. You might also want to describe the finished product. When you have completed setting up your telescope, it should be firmly set on the ground and the eyepiece should be just below the level of your eyes. In addition, you want to offer any kind of troubleshooting advice. What if the outcome is different than it should be? What should the reader do now? Anticipate some common problems for the reader, and if applicable, provide customer service information. You also want to think about usability testing. When your documentation is complete, you should do some usability testing with real users to see how real readers will react to it. Okay, I'm going to pause here for now, and please pick up the next screencast where I will discuss using style and delivery in layout design.